All right, some really evil letter arranging. Let's see what happens here. Poppies has 1, 2, 3, 4, 5, 6, 7 letters and obviously a bunch of identical P's. Without any restrictions, there are 7 factorial over 3 factorial ways that we could arrange that. 7, math left 4, divided by 3 factorial is just 6. Oops, 6. 840 ways that we could arrange this with no restrictions at all. If we have to start with a P, then basically that's not a choice. You can pretend that they just gave you oppies and asked you to arrange all the letters in that. The fact that they inked in a P before they let you get started doesn't make a heck of a lot of difference. So for that we'd say we have 6 things to arrange and 2 of them are identical. 6 factorial is 720 divided by 2 is 360. So if they don't give you any choice at all about a letter, don't even bother calculating it. Just say, okay, that's written in stone. That was done before I even got here. So I'm just going to worry about the things that I can control, these 6 things. If the first 2 letters are P, same thing again. That means we have OPs. This is poppies with 2 of the P's stolen out of it. And so now when we're arranging this, we just have 5 things to arrange, and there are no longer any identicals for us to worry about. So 5 factorial is 120. If all the P's are together, now they aren't saying they're out front, they just have to say that they're just saying they're together. Now we have the P block, and then we have O, I, E, S. So we have 5 things to arrange. And I hope you're thinking about internal arrangements right now, because that's what normally happens when you have a block like this. You can arrange the block along with the other letters just to get your sequence, but then you have to look inside that block and say, how many ways could I rearrange the things in here? The catch is, there's only one way to arrange the things in here because they're all P's. This is going to read PPP no matter what you do to shuffle the order. In other words, the internal arrangements in this are 3 factorial because there's 3 letters in there, divided by 3 factorial because they're all the same, which equals 1. So if you want to throw in a times 1, go nuts. It's not going to change the result. It's still 120. And if the first letter is P and the next one isn't, okay, so we've got oppies because they stole the first P and they put it out front. These are the only things that we're responsible for, are these 6 letters. So how are we going to do this? I'm considering going back to the space method just because I want to make sure I get this right. In this first space, we have 1, 2, 3, 4 things we can place which are not the letter P. And then after that, what do we have? We've got 2 P's, and we're going to have 3 letters left which are not P's. So for these last 5 spaces, we can go back to doing factorials and say I've got 5 factorial things that I can place here, but 2 of them are identical P's. All right. For this space, I probably could have done this some other way, and I certainly could have done it more confidently, but that just rattled me enough that I wanted to slow down and be careful. So we couldn't use either of the P's, so this letter is either the O, the I, the E, or the S. It could be any of those 4. Once that's covered, then we're done with we've taken care of the requirement that this letter not be a P. And now for the rest of them, it's wide open. It's just, here's 5 letters, scatter them any way you want. The only other thing we have to handle is that there are 2 identical P's, and we can't tell those apart. So what do we get for a total there? We have 4 times 5 factorial is 120. Divided by 2, that's 480 divided by 2. There should be 240 ways to do all that. Whew.